looking at number 5. Alright? We have this triangle here. This is the right angle, and this is your right angle. So we have two right angles. Alright, it gives us y, x, 3, 12, and z. So, and here we have to find each number. So, we want to first find the geometric mean, okay? And if you look back at it, it says to look at example 3. We turn back on page 533. If you looked at examples 3, it shows us how to go about setting this up, or we say, right, if we look at the theorems, right triangle geometric mean theorems. It's saying that, basically, the right triangle geometric theorem is saying that you have x over h is equal to x equal to h over y. Y, which is saying that h is equal to the square root of x times y, which is no different than what you just did on 1, 2, and 3. Alright, so, which we can say h here, in this case, would be the hypotenuse. So when we're thinking about h, this is the hypotenuse, right? Alright, well, it doesn't always have to be a hypotenuse. It could also be a leg theorem. So if we're talking about a leg, you can have c over b is equal to b over x. Alright, where b represents a leg, c is the hypotenuse. Alright, in this case, we are given two legs, so therefore we can assume that they are going to be the same length. Because really, if we think about it, we're talking about this triangle here, and then this triangle here, right? Or you can say the larger triangle, however you want to look at it. We're looking at two triangles. Alright, so we're saying this triangle here, and then we're talking about this triangle. So we know these two angles are congruent by 90 degrees. Alright, well then the other leg that has to be congruent is this one is congruent with this one. Alright, and then therefore this has to be congruent with this angle. Alright, so now that we know that, we can set it up. Just like proportion, but in this case, we are going to say there's going to be x. It's going to be x. We're going to set it up kind of like this, or like this one, it doesn't matter. So it's going to be x over 3 equals 12 over x. Alright? See here, this is a leg of each of the triangles. So we're using the leg theorem. If you look at geometric mean of the leg theorem. Alright, so you take 12, so this is going to be x equals the square root of 3 times 12. Alright? 3 times 12 is 36. Or we just break it down, so that's 4 and 3, and 2 and 2. If you remember, you go x is equal to the square root of 2 times 2 times 3 times 3. Circle our pairs and bring them out. So we get 2 times 3, which is 6. So therefore, we know x is equal to 6. So we just found something that we needed to know. X is equal to 6. Alright, the next thing we need to do. So, we put this in, right? Since we know this is right triangle, there's two ways we could do it. We could just keep doing the geometric mean, but if you don't like that way, you notice this right here is the right triangle. This is the leg, this is the leg, and this is the hypotenuse, because this is where the right angle is. So since z is a hypotenuse, all we have to do is this is the Pythagorean theorem. So then we can say 12 squared plus 6 squared is equal to c squared. Alright? If you do 12 squared in your calculator, you're going to get 144 plus 6 squared, which is 36, equals c squared. Alright? 144 plus 36 is 180. Let me double check that real quick. It is 180. So, the square root of 180 is equal to c. So, let's see if we can simplify it. Alright, so, break this down. Well, we can go 18 and 10, because 18 times 10 is 180. Break this down, we get 9 and 2. 9 is 3 and 3. 10 is 2 and 5. Alright? So we rewrite this. I'm just going to bring it right over here. So we get 2 times 2, this is the square root of all this, of 3 times 3 times 5. Circle our pairs. So we circle the pair, the 2 come out, the pair of 3's come out. And we're left with the 5. So you get 2 and 3. 2 times 3 gets 6. So we get 6 square root of 5 as our answer. So therefore, z is, so we cross this out, is equal to 6 square root of 5. So now we got 6 and 6 square root of 5. Now all we have to do is find this one, which you notice we can still use the Pythagorean theorem. So, we got that. Now let's do the Pythagorean theorem again. As you notice, this is a leg, this is a leg. So we can say 3 squared plus 6 squared is equal to y squared. So, 3 squared, let me write that here for you guys. 3 squared plus 6 squared is equal to y squared. Or you could say c. I actually use c instead of z on the last one, but either way works. So, 3 squared is 9 plus 6 squared, which is 36. 9 plus 36 is 45. So it's the square root of 45. Now let's break that down. So we break that down. So that's 9 and 5. Nothing like a board falling down. And then 3 and 3. Alright, so if you rewrite this, 3 times 5. 3 times 3 is 9, times 5 is 45, just to double check your work. We circle the pairs, take them out. So we get 3 square root of 5 as our answer. So now we have found all the values. And this is the value for y. Alright, let's do the next one. If we do the next one, number 6. Alright, number 6. You can start out exactly the same exact way that we just did. Let me point out something real quick though. For those of you that don't want to use the Pythagorean theorem every time. Alright, I'm going to write it over here. A different way to do this. There's nothing wrong with the Pythagorean theorem. You can still use it. It takes longer, as you notice. Or we could use the geometric mean way, which is a quicker way. But you don't have to use it unless you want to. Because sometimes you might not be able to find all of it with just the given information. So you would be forced to use the geometric mean way. But, just for example, alright, if you look at 532 on the very bottom page, it says, it has this triangle here. Triangle ABC. A, B, C. Alright, and then this is a right angle. So C is the hypotenuse, this is B, and this is A. As you notice, the sides and the side and angles are corresponding. So this angle A is with side A, angle B is with side B, angle C is with side C. Alright, and then it says, well, the short, and then it gives us another one, DAC. So we have this triangle here, which all this is doing is breaking up all the triangles that you see inside the triangle. ADC. So this would be D, this would be A, and this would be C. Let's make this a lowercase so it doesn't get confused with the angle. So D, and so therefore this would be the right angle. Angle D would be the right angle. And then the last one. So we have this, which is CDB. CDB. B. So this would be B, this would be C, and this would be D. Alright, and then this is your right angle. Sure, there you go. And there you go. So you have D. Well, instead of they put D, they decided to put this back at A. So this is actually A in this case. This would be B. According to this, they have H. And then C is one, instead 1. And you ask why? Well, because they're different triangles. They took a regular picture here, the main picture, which is ABC, triangle ABC. So we have this triangle, the overall triangle. So we have A, BC, C, and then we know this is the right angle, and then it's drawn down like this, so therefore this is the right angle, and this is D, alright? And if we look at the letter here, we know this here is A, this here is B, from B to B, right? And then this whole length here, from here to here, is C, alright? And then the next part, they go after the other one. So they put X here, they put Y here, and they put H here. And as you notice, ABC is the main triangle, the large triangle. ADC is the second biggest, and then the smallest would be CDB. And so those are all our triangles. And so now, when we do this, if you want to set it up the geometric mean way, you have shorter leg, the shorter leg over the longer leg. So when you look at this, it says which equals B over A, which our objective is to get two variables with the same spot so we can take the square root. So in this case, it would be x over the hypotenuse equals x over h, which equals h over y. Which, as you see, you take h times h, which is h squared, which gives you, so we get h squared is equal to x, y, or in this case, h equals xy, which that's what we want. Alright, and then if you look at another way to do this, you can do hypotenuse over the shorter leg. Alright, which that is saying C over B. We're saying C over B. Which they're talking about, we're always going back to this triangle here, and then going to the smaller ones. So we're saying C over B, which is equal to B over X, which is then equal to A over H. Alright, well, if you notice, right here we have B times B, which is B, so then we have B is equal to the square root of C times X, which that's what we wanted. And the last one, we have the hypotenuse over the longer leg, which they're saying C over A, which is equal to A over Y. Yeah, A over Y. Which you notice, that's what we want. So then that'd be A equals the square root of C times Y. So therefore, this is how we go about solving the rest of the problems. You can still use the Pythagorean theorem, which there's nothing wrong with that. Alright, we're going to stop there, and I'll make another video in a second. Alright. Thank you.